dx or dy? Yeah, I like dy on this one because it's easier to solve for x. So if it's easier to solve for x, then we're going to do dy. Of course, you actually can do any of the problems either way. You just might be making them insanely difficult if you choose the wrong one. All right, so now once we have determined that it's going to be dy, we're going to solve for x. Let's go ahead and do that. So we have x equals y squared, and x equals negative 2y squared plus 3. Now here's where, like, you're not familiar with graphing things that are in terms of x, so Desmos might be a great help to you. If you graph these on Desmos, or if you, just see YouTube, how do I do graphs with respect to x on my TI, if you want to know how to do that. I don't think it's very helpful. The TI is not very well set up for that. It doesn't do it very well. It's sort of a pain, and Casio, by the way, does that really well, graphing in terms of x instead of y. Desmos does it great. If you do graph them using some kind of software or computing device, try to pay attention to what patterns you see, because you actually can graph these by hand if you think about what's really going on. So x equals y squared, that's the inverse of y equals x squared. So I think y equals x squared is a parabola like this, reflect it over the y equals x line, and I'm going to get a parabola that looks like this. All right, so that's what x equals y squared looks like. Now I don't necessarily have to get all the graphs. You can do these without graphs, but there's sort of some guesswork as to how they intersect and how many times. I mean, you can figure out how many times they intersect. You have to determine which is the left and right, etc. All right, negative 2y squared plus 3. Well, now just think of this graph, which is x equals y squared, and say, I'm going to shift it plus 3, but I'm adding 3 to the x coordinates, so that's going to shift it right. And then I'm going to do a multiply by a negative, so that's normally reflected over the x-axis, but since we're in terms of x, it's going to reflect over the y-axis. So you have to think in terms of inverse functions. Everything's reversed in terms of x and y. This is going to be 3 right here, and this is going to be a parabola that goes like that. All right, we don't need to know what the y-intercepts of any of them are. We can just, graph this. So here's our area. We do need to know the intersection points. We need to know, what are these 2 points where the graph intersects. So we set the two functions in terms of y equal to each other. Transitive property of equality. X equals this, x equals that, so this equals that. All right, so y squared equals negative 2y squared plus 3. 3y squared equals 3. You probably should be able to look at 3y squared equals 3 and say it's plus or minus 1. Right, because y squared equals 1, so y equals plus or minus 1. So that means that this is negative 1 down here. We don't care what the x coordinate is. That's negative 1 right there. This is positive 1 right here. Okay, now I want to point out about symmetry again. This is, again, a symmetric function. It's symmetric with respect to the x-axis this time. So what I'm going to do is I'm going to use symmetry again, and I'm only going to do the top half of the figure, and then I'm going to double my result. So I'm going to say that the area is equal to 2 times the integral from, remember my limits of integration are y coordinates, so I'm going to be going from 0 to 1. That's my advantage of doing symmetry, is that I can take advantage of the 0 and not have to plug in the negative 1 and do everything twice. All right, now I have to go the right function minus the left function. So I have to know that this negative 2y squared plus 3, that was the function on the right. So negative 2y squared plus 3 minus y squared, and don't forget to put your dy there, right? So what you're doing here is you're doing the function on the right minus the function on the left, because that's going to give us a positive area. All right, so this is going to be, so I should simplify my integrand as much as possible. So negative 3y squared plus 3 dy, and then so I do my antiderivative. This is nice and easy because it's negative y cubed plus 3y. I'm going 0 to 1, so I have 2 times negative 1 plus 3. I normally like to write in the 0, but you guys are getting some experience. Let's just leave it off. The answer is 4. Not too shabby. All right, now it's time for you to do them. It's all fun and games when you're watching, but you got to do it. So your homework is going to be chapter 7 in your book. So if you're using the online version, find chapter 7. We're doing page 395. We're doing number 3 through 31 odd. It's kind of a lot. but it's really good to get a really solid grip on these. These are always on the AP exam, and it's just one of the most fundamental ideas of calculus, something that applies to many, many, many things, not just area. So have at it.